Why is firmware important for OS boot process? Have you ever wondered what happens when you power on your computer? The magic begins with firmware, a key player in the operating system boot process. Let's break down its importance in a way that's easy to grasp. Firmware is the first software that runs when you turn on your computer. It is stored in non-volatile memory, like electrically erasable programmable read-only memory or read-only memory, located on the motherboard. This software prepares your system to load the operating system. When you power on your device, the firmware, which can be either basic input-output system or unified extensible firmware interface, kicks into action. The first thing it does is perform a power-on self-test. This test checks essential hardware components like the central processing unit, memory, keyboard, and storage devices. This step ensures everything is functioning correctly before moving on. Once the hardware is verified, the firmware configures the settings needed for the operating system to work smoothly. This is crucial because if the hardware is not set up correctly, the operating system may not function as intended. After initializing the hardware, the firmware locates the bootloader. The bootloader is a small program that loads the operating system kernel into memory. In basic input-output systems, this involves reading the master boot record from a storage device. In unified extensible firmware interface systems, the firmware reads a specific file path, often a file with the extension UEFI, from a FAT32 partition to load the bootloader or operating system loader. Unified extensible firmware interface has advanced features that basic input-output system does not, such as the ability to return control back to the firmware if needed. It also supports modern file systems and larger storage devices, making it a more flexible option. The role of firmware is vital because it acts as a bridge between the hardware and the operating system. Without firmware, the central processing unit would not know how to initialize the hardware or where to find the operating system to start it. Different operating systems depend on firmware to provide a consistent environment during startup. For instance, Windows operating systems use a program called Boot Manager, while Linux systems often utilize the Grand Unified Bootloader. Each operating system has its own method for loading the kernel, but they all relying on firmware to get the process started. In practical terms, firmware ensures that your system hardware is ready and that the correct operating system loader is found and executed. This enables a smooth and reliable boot process. The foundational role of firmware applies across major operating systems, making it an essential component for system startup and management.